We have spent the last few lessons talking about compounds and coming up with their chemical formulas and naming them. And now what we do is we move into a section of our unit where we take these compounds and we combine them in different ways to get chemical changes. Okay, so remember that chemical changes are when we produce something new. There's clues that tell us that we have a chemical change. So, clues like light is produced, heat is produced, a precipitate is formed, gas is being produced. So in all of these cases, we're talking about chemical reactions. And there are 5 main types of chemical reactions, which we will get to in the next lesson. But for today, we're just going to look at reactions in general and how we balance them. And it is very important that we have reactions that are balanced. And we'll explain what that is in our little short note right now. So you'll notice that the title of this note is actually Law of Conservation of Mass. And that is because in order to balance any chemical reaction, you have to follow the law of conservation of mass. So when we talk about the law, we have to understand that during a chemical reaction, matter is neither created nor destroyed. Okay, you cannot make more matter. You cannot destroy it and have it, just sort of go into oblivion. The number of atoms of every element on Earth are constant. They are just simply they're just simply rearranged, and we will form new substances with those atoms. So sometimes we'll break a compound down and we'll break it apart, but the atoms are still there. And then we'll take those atoms and create some new, different product. Okay, so we don't actually lose any atoms of elements along the way. They're just simply rearranged. So when we're dealing with a chemical reaction, we know that we always start with reactants and then we make products. Okay, so our reactant molecules or our reactant compounds are rearranged and they are converted into something new, which are called products. And here's our law of conservation of mass. So based on the law, the total mass of reactants must equal the total mass of products. And this is a law that you should have learned in grade 10. But we just want to remind you of it because, again, it is the basis of us to balance a chemical reaction. So it says this is easy to see. So this law, right, conservation of mass, is easy to see with physical changes. So for example, if we took some water, so that you can tell by this reaction, I would have water in the solid state, which would be the same as saying that I have ice. Okay, so let's pretend that I have 5 grams of ice and I place it in a cup. And then I let that cup of ice just sit out on the kitchen counter at room temperature. We know what's going to happen, okay? We know that that ice is going to melt. And then we know that that ice is going to turn into water in the liquid state. Okay, I don't know if you can see that there, but on your summary note, you can. Water in the liquid state. What should that mass of liquid water weigh? It should weigh 5 grams of water. Okay, so liquid water. And we should not lose any mass, right? This is what the law of conservation of mass states. And we should not gain any mass unless you spill the cup and you lose some water literally out of the cup, or you drop something in the cup by accident. But the number of water molecules have not changed. They've just changed their state. When we do chemical changes, okay, so where we see that we have reactants and products and they look very different from each other, sometimes it's harder to notice the law of conservation of mass. But either way, it is true, and you should not be losing or gaining masses of atoms as you move through these changes. So in order to satisfy the law of conservation of mass, chemical reactions are balanced using coefficients, very important, in front of the chemical substances. This allows the masses of both sides of the reaction to be equal. And I'm going to show you how we do this here with 4 examples. So notice what I say. I say prove the law of conservation of mass, okay, otherwise known as balance the following reactions, okay? So notice that I have a reaction here and I have the words, right? The chemical names of my compounds. So we're going to convert these into chemical formulas. So here's sodium chloride, okay? And sodium is a metal, chlorine is a non-metal. This is ionic. I need to go and look up the charges of each of those ions on the periodic table. And then I do the crisscross rule and I bring those charges down, which when they're ones, we don't see them. Then I have silver oxide. So silver is a metal, oxygen is a non-metal. So that means I need their ion charges. So I can do the crisscross rule. You go and you find silver on the periodic table. Okay, his symbol is Ag, and he's got a charge of +1. Oxygen has a charge of -2. We do the crisscross rule, and we get Ag2O. Sodium oxide. Okay, so I mean, if we have ionics to start the reaction, we're going to have ionics still to finish the reaction. So I can just go and look up the charges. Sodium has a charge of 1. Oxygen has a charge of 2. I do the crisscross rule, and I come up with that formula. And then silver chloride, silver has a charge of 1, chlorine has a charge of 1. I just come up with the formula of AgCl. Now I need to balance this because they're not balanced, right? If I look here, I'm going to just switch pen colors to make it a bit easier. I have 1 sodium, but I have 2 sodiums here on the product side. So right off the bat, I know I've got to deal with that. Then when I look at silver, here's silver, and I have 2 of them, all right? So this is where these little numbers come from, and we know this from bonding. I only have 1 silver on the product side. So how do we balance our elements? Well, the only way to balance elements is to put coefficients in front of your compounds, okay? So watch what I do here, which is a mistake, okay? If I need 2 sodiums, I cannot come along and just stick a 2 in front or behind that sodium of sodium chloride. I can't do that because if there was a 2 there, that would imply that chlorine has a charge of -2, right? And that we're bringing down the charges in the crisscross rule. And I know that that's not the case, right? Chlorine does not have a charge of -2. So I can't do that, okay? I cannot do that, and I can't, back to my blue here so I can just get my chlorine back. I cannot just add in my own numbers, okay, and change a chemical formula. But what I can do is I can take this 2 and I can place it out front as a coefficient. And when I do that, the 2 applies to sodium, but the 2 also applies to chlorine. So now I gotta go and adjust chlorine on the product side. So here is chlorine, part of AgCl. Again, I cannot do that, folks, okay? I cannot put a 2 after chlorine. That implies that the charge on silver is a 2, and it's not. But I can put a 2 out front of the whole compound, and now I just change the amount of silver. So remember, this 2 is for chlorine, but this 2 also applies to silver. So I come and I find silver on the reactant side, and we already have 2 of them there. So that's good. So I don't need to balance it. And then I check out everything else. Oxygen is 1, and over here, oxygen is 1. So those are both balanced. Here's sodium with 2, and again, we already balanced that. So everything is good here. Let's move on, and we will deal with the next reaction. So here I take hydrogen and oxygen. And hydrogen is one of these elements that when it's on its own, it's a diatomic element. Okay, so H2 is the formula for hydrogen. It always exists in pairs. Oxygen is the same, always exists in pairs. And then we have water, which everybody should know the formula for water, which is H2O. When I look at this, right away I can notice that the hydrogens are balanced. I have 2 of them on both sides, but oxygen is not. So I have 2 oxygens on the reactant side, and I only have 1 of them on the product side. So I have to bring a 2 in front so that I can balance those oxygens, okay, because I need 2 from the reactant side. So that's done. But now I've also changed the number of hydrogens. So I have 2 times 2 of them. And so I need to come over to hydrogen and I have to put a 2 in front to balance them that way. And that's it. That's done. Let's move on and let's do the next example. Okay, now this is one where it's a little bit more involved. There's, bigger formulas that are listed here. And we also have some polyatomic ions, right? Remember that you can tell when you have a polyatomic ion. IDE means you have the element alone. 8 or ite implies that you have a polyatomic ion. So let's come up with the formulas here. I'll just do this. You have had practice with nomenclature, and for balancing, we're just going to we're just going to give you the formulas, okay, as we go. So aluminum has a charge of 3. There's nitrate's formula, and that will be a 3 brought down from crisscross rule. And then copper 2 fluoride, again, is the element fluorine. And they're telling us that copper has a charge of 2. So we know that that's his charge. And we just crisscross that down. All right, so let's balance this. And again, where you decide to start balancing really doesn't matter. Just pick something that's not balanced, right? And go from there. So as I glance across, I can see all my metals are balanced, right? I have, 1 aluminum here and I have 1 aluminum there. I have 1 copper here, 1 copper there. But it's the anions, the negative ions that are not balanced. So let's start right here since I'm at the end of the reaction. I have 2 fluorines and then I have 3 on the other side. And whenever you have an odd, even situation, right? This is odd number, 3 is an odd number. 2 is an even number, okay? Then what you do is you always multiply both of those elements by the opposite number to make them even, okay? Or to make them equal, sorry. So what that means is if there's a 2 here and a 3 over here, I'm going to take the 3 and multiply it by the 2. And I'm going to take the 2 and multiply it over there by the 3 fluorines. And now what's happened, let me just erase my odd even situations here, is that I have 2 times 3 fluorines, which is 6, and 3 times 2 fluorines, which is 6. Okay, so those are now both balanced. But again, I've come along and I have now adjusted the number of coppers that I have. So I'm going to go to copper on the other side and I'm going to adjust there and put a 3 in front. And then I'm going to adjust the number of aluminums. Okay, so I adjusted that. Now I have 2. I'm going to put a 2 in front. And then let's check what's happening with these nitrates. Okay, so I have 3 times 2 nitrates for a total of 6. And then over here, I've got 2 times 3 nitrates for a total of 6. So everything is balanced this way, okay? My advice is with polyatomic ions, do not separate those. Sometimes students learn in junior science to separate the nitrogens and the oxygens. Don't do it. Treat it as a whole. That's what a polyatomic ion is, right? So a nitrate has the formula NO3, okay? And treat it as one NO3 ion, or if there's a subscript after it, like a 2 or a 3, that you have 2 nitrates or 3 nitrates. It's much easier for you to balance that than if you separate everything. And then I'll do this last one for you as well. Okay, so I'll just come up with the formulas for these. So sodium, actually I'm going to switch my pen color just to keep it consistent. So sodium phosphate, so again, this is a polyatomic ion. It will be Na3PO4. Hydrochloric acid is a formula you may know. It's HCl, okay, so it's hydrogen and chlorine. Everyone should know sodium chloride, which is salt, NaCl. And then we have trihydrogen phosphate. Okay, so trihydrogen would be 3 hydrogens, and then a phosphate would look like that. So let's just go through this and balance it quickly. Okay, and again, a lot of you will be able to go through and balance these easily. Some of you might need a little bit more practice with this. But I would start here. Okay, I have 3 sodiums, and so I want to balance my sodiums over here with a 3 out front. I now just changed the number of chlorines. I have 3 of them. So let's go over and give me 3 chlorines from that HCl. I just changed the number of hydrogens, but I need 3 on the other side. So it's all balanced. Okay, it's all good. So you can carry on and try to balance these reactions that I've attached here in your summary note. And then there are answers provided for you if you just keep scrolling down. All right. As usual, be in touch if you have any questions about balancing. And the resource note, as usual, is very, very good. Go through the resource note. They have little videos set up for you there that they show you how they balance. And again, they give you reactions and you can balance them on your own, check your answer. It's pretty good.